Next problem in single proportion test. In a random sample of 81 items taken from the large consignment, some were found to be defective. If the standard error of the proportion of defective items in the sample is 1 by 18, find 95% confidence limit of the percentage of defective items in the consignment. Given sample size n is equal to 81, standard error of the defective item, right? Standard error of the proportion of the defective item, that is E, 1 by 18, SE or E. We know standard error formula is root of PQ by N. So Q is equal to 1 minus P. So root of PQ by N is equal to 1 by 18. Therefore PQ by N squaring both sides, right? Which is equal to 1 by 18 square, 324. So PQ is equal to N by 324. N is equal to 81. So 81 by 324, that is equal to 0.25. So P into 1 minus P is equal to 0.25. But Q is equal to 1 minus P. That is what we are using, P into Q, that is P into 1 minus P. So multiplying P minus P square minus 0.25 is equal to 0. That is multiplying by minus P square minus P plus 0.25 equal to 0. So this is quadratic in P, so we are factorizing this one. So P minus 0.5 into P minus 0.5. So P is equal to 0.5. So to find the 95% confidence limit, formula is P plus or minus 1.96, because 95% confidence limit, right? Z alpha value 1.96 into root of PQ by N. Substituting these values, 0.5 plus or minus root of PQ by N is nothing but the standard error, right? So 0.5 plus or minus 1.96, 1 by 18. So 0.5 plus or minus 0.1089. So first lower limit of the interval. So take 0.5 minus 0.1089, that is 0.3911. Then upper limit of the interval, 0.5 plus 0.1089, that is 0.6089, right? So that is the 95% confidence limit. Next problem. Dr. Benjamin Shockley, a noted social psychologist, right, psychologist, surveyed 150 top executives and found that 42% of them were unable to attend fractions correctly. Estimate the standard error of the proportion and construct a 99% confidence interval for the true proportion of top executives who cannot correctly add fractions, right? So we will see the solution. Given sample size, so 150 executives, so N is equal to 150. Proportion of a executive who were unable to add fractions correctly, that is P, that is equal to 42% they have given. So 42 by 100, 0.42. So now Q is equal to 1 minus P, that is equal to 1 minus 0.42, that is equal to 0.58. To find the standard error for the proportion formula is root of PQ by N. Substituting the value root of 0.42 into 0.58 by 150, so we will get 0.0403. To find the 99% confidence interval, the formula is P plus or minus Z alpha root of PQ by N. Here 99% is Z alpha, right? That is 2.58 from the table. Substituting these values, so 0.42 plus or minus 2.58, 0.0403. So taking the lower limit, that is 0.42 minus 0.104, 0.316. Now upper limit, 0.42 plus 0.104, 0.524 upper limit. Next problem. A speed reading course guarantees a certain reading rate increases within 2 days. The teacher knows a few people will not be able to achieve this increase. So before starting the guaranteed percentage of people who achieve the reading rate increase, he wants to be 98% confidence that the percentage has been estimated to within plus or minus 5% of the true value. What is the most conservative sample size needed for this problem? So we need to find the sample size. What is that? A speed reading courses. So they will train you how to read speedily, right? Within 2 days they are guaranteed, right? They will increase the speed reading of one person, right? Few people not teachers known a few people not able to achieve this increase. So in that course teacher understand that some of them are not able to increase their speed of reading, right? So before stating that guaranteed percentage of people who achieve the reading rate increases, so before confirming to the public, so if you join, they will advertise like this, right? If you join this course, we will sure 100% you will read very speedily, right? That is the percentage. 95% you will speed you will read speedily, right? So that is what, before stating the guaranteed percentage of people who achieve the reading rate increases, he wants to be 98% confidence, right? The estimate within plus or minus 5% of the true value. So true value means you can accept the error. Error is equal to plus or minus 5%, so 0.05. So we know sample size n is equal to z alpha square pq by e square. So we have to put the value of 98% z alpha value, right? Here sample proportion p is not given, so let us assume p is equal to 50%. Note that. So 0.5. So q is equal to 0.5. So sample size n is equal to, so that z alpha value is at 98%, 2.33 from the table, 2.33 square, 0.5, 0.5 by 0.05 square, which is equal to 542.89, approximately 543 sample sizes. Next problem. In a quality department of manufacturing points, at a time of dispatch of decorators, 30% of the containers are found to be defective. If a random sample of 500 is drawn with replacement from the population, what is the probability that this sample proportion will be less than 25% defective? Given sample size n is equal to 500, right? If a random sample of 500 is drawn with replacement from the population, right? So n is equal to 500. Given population proportion p is equal to 30%. 30 means 0.30. So q is equal to 1 minus p, 1 minus 0.30, that is equal to 0.70. To find probability of sample proportion less than 25%, so to find probability of small p less than 25%, that is p less than probability of p less than 0.25. So subtracting capital P on both sides, so probability of p minus capital P less than 0.25 minus p and divided by root of pq by n. So probability of p minus p by root of pq by n less than 0.25 minus p by root of pq by n. So substituting the value, we know test statistics z is equal to p minus p by root of pq by n. So p is probability of z less than 0.25 minus 0.35 by root of 0.30 into 0.70 into divided by 500. So that is equal to probability of z, which is less than minus 2.439. So from the table z is equal to 0, this is z is equal to minus 2.439. So less than that, so this is the area, right? So this is 0.5 right area, right side of 0 z is equal to 0, left side of 0 z is equal to 0, 0.5. So left area minus area between z is equal to minus 2.439 to 0, that is equal to 0.5 minus probability of minus 2.439 less than z less than 0. So that is equal to 0.5 minus probability of 0 less than z less than 2.439, because we are using symmetric property of normal curve. So from the table you will get 0.5 minus 0.4925, that is equal to 0.0075, right? So that is the probability value, right? Thanks.